Think about it. What would you do if you could solve a problem that would take 20 million years in just 15 minutes? If you're thinking that this is just exaggerated internet talk or that it can't possibly be true, I completely understand. We've seen many promises out there, but what I am about to show you is not theory. It is a real result that is officially proven, and it changes everything. Say a comment now. Is anything allowed for technology to evolve with promises of a better future? Leave your quick opinion here in the comments before I even tell you how science is turning 20 million years into 15 minutes. Remember everyone, if you like our project, besides your opinion, leave a like now so you don't forget. It helps this project a lot to continue bringing videos to you. Thank you. Let's get to the facts. This is the first concrete proof of quantum advantage using light, and what it has the potential to do is simply transform the way we use computers, how machines learn, and our reality. Get ready, because the change in our ability to do things is so huge that what you know about technology is about to be rewritten. Connect the final R plus I dash instantaneous, maintaining the fast flow. The most important news comes from researchers at the Technical University of Denmark who published a very important study in the journal Science. They used a concept called entangled light, which is a real phenomenon in quantum physics. With this light, they managed to solve a learning problem. To give you an idea, the computer we use daily would need 20 million years to perform this calculation. They did it in 15 minutes. I know it sounds like something from another world, but it's the kind of discovery that creates a clear line, you know? What we could do before and what suddenly we can do now. The scientists were trying to understand the functioning of a quantum system that had a lot of noise, a lot of interference. Think about trying to map a super complex device with many parts. In our current computers, called classical, the more complex the system, the harder it gets. The difficulty grows in a way that the task becomes impossible or takes an eternity, as we saw. But quantum physics, quantum mechanics is different. It can ignore normal rules. They did the following. They created two beams of light that were entangled. Think of entanglement as two little balls connected in a magical way. If you move one, the other reacts instantly, even if they are on opposite sides of the universe. The physicist Einstein himself found this very strange and called it spooky action at a distance because it didn't make sense in traditional physics. In the experiment, one beam spies on the system and the other serves as a comparison. When they are measured together, entanglement cancels out noise, interference, and manages to extract much more information from each measurement than any common technique could. This is not just about being a little faster. It is a completely new way of doing things. It is the difference between assembling a puzzle piece by piece and suddenly having the entire picture ready in front of you. Professor Ulrik Lund Andersson, who led the research, says this is the first clear evidence of quantum advantage in a system that uses light. And the most impressive thing is that they used common laboratory equipment, which you find anywhere in the basement of a university. Maybe you're thinking, but why does this matter to me? It's not just about having a faster computer. It's about having a completely new capability that simply doesn't exist in the world today. Think of machine learning programs, artificial intelligence. Today, to train artificial intelligence, we need an enormous amount of data and immense processing power. But what if entangled light could cut down this learning time in a way we can't even imagine? Think also about detection technologies. And if we could identify materials, detect diseases, or monitor environmental changes with a precision and speed that are impossible today? But the truly shocking part, and the one that raises serious questions, is the connection with biology. Scientists from the University of Chicago brought surprising news. They created biological qubits. They used glowing proteins, the same ones that make jellyfish luminous to build quantum sensors inside living cells. I will repeat to make it clear. We are talking about transforming your cells into quantum computers. These biological qubits can sense and detect magnetic and electrical signals within the cells on a tiny scale. The genius part is that the researchers managed to do this without the need for all the extreme cooling and isolation that quantum technology always requires, because they use the natural proteins that already exist. The source of this information is an article from the University of Chicago about biological qubits. This has immense potential for medicine, for diagnostics, and for understanding life. But that's where we need to be very, very careful. When we start integrating quantum technology into biological systems, we are crossing very important boundaries. It's not just about having a better device. It's about messing with the very foundation of life, with what has been developed with an intelligence that we don't fully understand. This same quantum physics, which solves problems that seem impossible, can, on the other hand, disrupt our biological systems in ways we cannot predict. Think of areas that rely on understanding complex things. Digital security. Quantum can create codes that no one can break, or, on the contrary, break all current codes. Economy. It can optimize markets in ways we've never seen. Health. It can simulate the creation of new medicines and molecules much faster. Climate. It can create highly accurate models of how the planet behaves. All of this changes. But by combining the quantum with the cells, we enter a field that changes the essence of what it means to be human. One of the scientists, Jonasko Nørgaard Nielsen, said something very powerful. What satisfies us is that finally, we have found a quantum system capable of doing something that no classical system will be able to do. Pay attention to this. It will never be done with our current technology. If we apply this to biology, we are not just gaining calculation speed, we are messing with what defines life. Looking at the big picture, what makes me think a lot is that this is just the beginning. We are approaching limits that perhaps we shouldn't reach. Quantum physics is no longer just theory. It is becoming a practical technology that is merging with biology. While using light and common equipment for the first advance and jellyfish proteins for sensors inside cells, there is something else happening that makes everything even more intense. A French startup called Alice and Bob announced that they managed to create qubits that last more than an hour. To give you an idea of the scale, normal qubits, which are the basic component of a quantum computer, last only microseconds before disappearing. The most advanced quantum computer that IBM has reaches 400 milliseconds. Alice and Bob achieved more than an hour. That's millions of times longer. This is where we need to stop. When we combine quantum learning, which solves what would take millions of years in minutes, stable qubits, which last hours instead of a blink of an eye, biological qubits, which operate inside cells, we are not just improving technology, we are erasing the line between what is technology and what is life. Why is this stability so important? Today, quantum computers make many errors. With every 100 operations, there is already an error. Our normal computers make far fewer errors. To compensate, scientists need millions of physical qubits just to create a few logical, reliable qubits. But with qubits that last an hour, suddenly 200 times fewer pieces are needed. The price drops, the complication decreases. And if you add to this the biological qubits that operate within cells, technology not only does calculations, it merges with life. At this point, we need wisdom, not just invention. Quantum physics that gives us superpowers can also damage biological systems that were perfectly designed. We are heading towards a future where the line between human and machine, natural and artificial, will become increasingly blurred. Do you remember that we talked about the evolution of artificial intelligence being accelerated? The quantum is following the same path, but the consequences are much greater, especially when it merges with our biology. When a quantum system learns super complex problems in minutes, stays powered for hours, and operates within cells, it's not just a small improvement. These are capabilities that redefine what it means to be human. If you are thinking about the future of your career, your business, or where to invest, pay close attention to this. We are witnessing the convergence of several quantum advances that create something entirely new, but that requires serious reflection from us. Quantum learning shows that it solves what a regular computer never will. Stability shows that it is becoming something practical and accessible. Biological advancement shows that this technology is heading directly into living beings. Alice and Bob want to have 100 logical qubits by 2030, which would already be enough to completely change materials science, the way we make batteries, solar panels, and even more efficient superconductors, which would accelerate our current computers. The main point is, whoever understands this union of technologies first, whether a company or an individual, will have access to capabilities that competitors using outdated technology simply will not be able to replicate. But we have to be very responsible with the application in biology. If we start to put quantum technology into living cells, we enter a field that interferes with the natural order of things and with our purpose. These are not just technical innovations, they are profound questions about what we are born to be. The idea of having quantum sensors in cells is great for medicine, but it is also a fundamental change in biology as it is. We have to ask ourselves, just because we can mix the quantum with life, should we? This moment is more important than the internet, more important than the cell phone, more important than artificial intelligence, because quantum physics not only changes how we process information, it can change who we are. The question is not whether quantum technology will change everything. The question is whether we will have the wisdom to deal with these changes without losing our human essence in the process. The future is not many years from now. It is happening in laboratories right now. While most focus on the new app or the latest AI trend, quantum researchers are unraveling the fundamental codes of the universe. And now they are ready to put this technology inside living cells. It's the contrast, 15 minutes versus 20 million years, qubits of 1 hour versus microseconds, and now quantum sensors inside living organisms. It's not just a small improvement, it's a different category of existence. By 2030, which is just around the corner, only 5 years, we may have quantum computers that solve problems in materials science, medicine, and security that a regular computer will never be able to handle. But we are also looking towards a future where the boundary between technology and life disappears once and for all. At this moment, we need innovation and wisdom. The intelligence that created the complex systems of life must guide us to know how far to go with these quantum capabilities. The question is not whether the quantum will change everything. The question is whether we will have the wisdom to use these capabilities in a way that respects the limits of what we were created to be. If you want to stay updated on these innovations that are changing human capability and follow the conversations on how to use this responsibly, click to subscribe. Because believe it, when quantum learning, quantum stability, and biology come together, everything changes. Now that you've seen the union of all this, problems of millions of years solved in minutes, qubits that last hours, and sensors inside cells. The question is, should we really move into this quantum era? Share your deepest thoughts in the comments about where you think the boundary lies between innovation and what it means to be human. This video doesn't end now. It continues with us chatting in the comments. If you find this video interesting, I invite you to become a channel member and like this video. Up here on the right side, I will leave a video suggestion for you to continue with me.